All right. Okay, so we're gonna leave off. We're gonna continue where we left off. Okay, so this is trigonometric ratios part 3. Okay, so if you're in my period 2 and 4, I already taught this. I think Thursday and Friday last week. But if you're in my period 5, 6, 7, this is the part that I did not get to teach you guys. So yeah, so this is for you guys in my period 5, 6, 7. Okay. So let's say we have another person. I don't really know who to pick on at this point. Let's use a quiet person. Andrew? Okay. So let's say Andrew is here. So let's say he is standing a certain distance away from a tree. Okay. So here's a lovely tree. Here's a lovely tree. And let's say there's a little bird. He sees a little bird in the tree. Big bird. Really big bird. Okay. He sees the bird, and from his point of view, he looks at the bird, and the angle of elevation from the top of where he's looking at is going to be 40 degrees. Okay. So what we know is that the angle of elevation is going to be 40 degrees. Let's just assume he's 5 feet tall. I really don't know if Andrew is 5 feet tall or not. Might be. But anyway, so let's say we wanted to find the height of this tree. That's our goal. What if we wanted to find the height of this tree? And we're given that Andrew is standing 20 feet away from the tree. Okay. So this is the type of experiment that you will probably do in class, probably in the middle of April, maybe the end of April. I haven't figured that out yet. But what you guys are going to be doing is going to be going outside and actually trying to figure out the heights of certain things. Okay? But this is just an example of what you could do. Okay? So, first, what we know is that Andrew is 5 feet tall. So we know that part of this height of the tree is this tree is at least 5 feet tall. It's going to be at least 5 feet. Our goal is to solve for this length. Okay? So this is the length that we don't know. Let's call it y. Okay. So what this means is that the total height of the tree is going to be Andrew's height plus this height here. Okay? So let's say, let's try to see if we can solve for y. Let's try to find an expression to solve for y. Okay, so in this case here, what I see is that we have a 40-degree angle. So we know that the tangent of 40 degrees is going to equal the side that is opposite of the 40-degree angle, which is y. And you divide that by the side that is adjacent or next to this 40-degree angle. So that would be 20 feet. Okay? So from here, you need to find the tangent of 40 degrees. You gotta make that look nicer. Or turn into a decimal. So tangent of 40 degrees is going to be 0.8391. Okay? So tangent of 40 degrees is going to be 0.8391. If you don't believe me, put it in your calculator. Tangent of 40, 0.839 round, 8391. Okay? So this equals y divided by 20. So yeah, you could do the same thing. Put this over 1. and cross multiply. So put this over 1, cross multiply. This is going to be 20 multiplied by 0.8391 equals 1 times y, which is y. So if you had to go ahead and put that in your calculator, the height above Andrew's head is going to be 20 multiplied by 0.8391. So that means this height is going to be 16.782 feet equals y. Okay, so the next step what you would do is, let's say you want to find the height of the tree. That was the original problem. You want to find the total height of this tree. If you want to find the total height of this tree, basically this is going to be h equals the height found from the trigonometric ratio, the tangent ratio, plus Andrew's height, which we assume is 5 feet. That means you substitute this in. This is 16.782 feet plus 5. That means the height of this tree is going to be about 21.782 feet. Okay, so I know some of you guys look at decimals and probably think it's a mess, but honestly, that's how it is in real life. Not everything is perfect. A lot of things have decimals and fractions. It just so happened everything that I worked with earlier had a lot of whole numbers, so we just have to get used to it. Okay. I have a few more examples before I finish off this section. Okay. So this will help you out on the homework if you don't quite understand how to do it. Okay. So this is find the unknown side length. Okay. Find the unknown side length. So let's say we're given a few triangles. I have this one here, this one's A, this one's B, this one's C. So it's 12, this is 50 degrees. And I've given this other triangle, this other right triangle. This is D, this is E, and this is F. This is 8, and this is 21 degrees. Okay, so in this one we want to solve for length BC. In this one we want to solve for length DE. Okay, so if we want to solve for BC, what we would do from here, we know this is a 50-degree angle. Since we know this is a 50-degree angle, we know that the tangent of 50 degrees is going to equal the side that is opposite of the 50-degree angle, which is 12. The side that is next to or adjacent to this 50-degree angle is side BC. Okay, so from here, find tangent of 50. Use the table if you wish. I'm just going to use a calculator. This is 1.1917 equals 12 divided by BC. Okay, this is where some of you seem to mess up with your algebra skills. If you're not confident with your algebra skills and multiplying BC on both sides and dividing by 1.1917 to solve for BC, put it over 1. Okay, so cross multiply. This is BC multiplied by 1.1917 equals 1 times 12. So here, what I want to do is if I want to solve for BC, divide this through. So this is going to be 12 divided by 1.1917. So that means the length BC is going to be about 10.07 units long. Okay. So this next one, we want to solve for DE. So now if we want to solve for DE, we want to use this 21-degree reference. Okay. So let's say we wanted to solve for DE. So now what we do is the tangent of 21 degrees is going to equal the side that is opposite of the 21-degree angle. So that's going to be side DE, which is what we don't know. And we divide that by the adjacent side, the side that is next to the 21-degree angle. So this is going to be EF, or 8. Okay. So from here, you could do just like how I did the other problems. I'm just going to show you a different way. You could just do this. You could multiply by 8. You could multiply by 8. These 8's cancel out. If you're too lazy to put anything else, just put 8 times tangent of 21. And that will give you the answer. So that means DE equals 3.07. Okay. All right. And that concludes the tangent ratio lesson. Okay. In the next video, I'm going to describe the sine and cosine ratios. That shouldn't take too long, I believe. Okay. If you are watching this, good. If you are not watching this, well, I hope you understand it eventually. Okay. Bye.